what does this arc look like?
There's a picture of it right here. That's it.
This over here is the brand new Intel Arc 580, and would you believe me if I told you that this $179 graphics card is better than an RTX 3080? You wouldn't believe me, would you? Well, you're gonna have to watch the rest of the video and then find out.
Looking for a cheap way to license your Windows? Check out WhoKeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out whokeys.com in the video description below.
So a little bit of a context, where does this card line up? So we've got the Intel A770, which currently is the most powerful GPU from Intel. Then we've got the A750, which are the Intel kind of 7 series. You know, we have i7 on the CPUs, we have 7 series on the GPU as well, which are the A7 series, 750 and 770. Then we have this, which is the A580, which is the i5 kind of series of GPUs, as you can see. So this is where it kind of slots in there. And then we have the A380, which is the i3, you know, like the i3s we have. This is not i3, but this is the 3 series of Intel GPUs. Then the i5 and then the i7. Interestingly, we haven't seen the A9 series of GPUs yet. So I can't wait for the next generation, because I think then we really start to compete with the Intel's 80 series or perhaps maybe even 90 series GPUs. So who's the competitor of this GPU? So Intel's saying that this is basically, instead of the RTX 3050 or Radeon A6600, something like that, GPU. We're looking at the creator benchmarks, because what is very, very interesting about this card is that this card has 2 of the Intel's best media engines inside. You know, you have to get the 80 series GPUs from Nvidia, so that's about $1,000+ to get dual encoding or dual media engines inside the GPU. For example, the 4070 Ti actually has it as well, so it's a little bit less than $1,000, but 4080 and 4090 has dual encoders on desktop, that is. On laptops, actually 4070 Ti doesn't have that, but only 4080 and 4090 has dual media engines in there. But with this $179 card, we do have dual media engines, which are absolutely amazing for video editors, because if you didn't have Intel QuickSync with your AMD or Threadripper system, for example, then suddenly with this $179 card, you can have it. And we're going to look in a moment how these perform in video editing benchmarks. But some of the specs then. I've got RTX 3050, A580, A770 and A750 here lined up there. And we can see that the process node is actually smaller, or, you know, newer than the RTX 3050 GA106 GPU, which has 8nm Samsung process, but this one has 6nm TSMC. Interestingly, Intel is not using their own chips for this, but outsourcing it for their GPU line. Looking at the CUDA cores, which they're not actually called CUDA cores in Intel here, and this is completely different architecture, and different GPUs, you know, call them differently. AMD calls something differently, Intel calls something differently, and then Nvidia calls it differently. We've got CUDA cores, then we've got render slicers and XE cores, and you know, TMUs and all sorts of different things, but certain kind of cores do similar tasks. So these are kind of the similar things that we're comparing between GPUs, even though technically you can't compare these to each other because they're a little bit different, if that makes sense. In terms of the CUDA cores, whatever, you know, you're familiar from Nvidia, the A580 has 3072, which is a little bit more. TMUs, we have quite a bit more, 192, and as you can see, it's less than the A750 and A770. For tensor cores, that's why we have stars there, we have 384, and RT cores, interestingly, we have exactly the same as an RTX 3050. We're using GDDR6, 8GB of it, and the memory bus is 256, which is a much higher end GPU spec than what we see on the 3050, which only has 128, so double that, and the memory bandwidth, as you can see, is more than double that as well. We're using PCIe 4.0 bus interface and X16 lanes for that, even though you don't actually need it, but just in case you're backwards compatible compatible and want to put this into PCIe Gen 3 or Gen 2 motherboard, you're not going to be limited by 8 slots, which RTX 3050 might do. And the card is $179 in terms of a suggested retail price. Maybe it's going to vary a little bit higher, a little bit lower, but it's quite a bit cheaper than the RTX 3050, which I can see is $200+ right now. And the A750 is $230+, and the A770 is $300+. So it's quite a bit cheaper and has the price going for this card. But the question is, will it perform according to its price? We'll have a look. If you want to check out my test bench setup, I'm going to leave it in the description below. Firstly, let's have a look at Geekbench 6. And here we can see the A750 is about 9% faster in the OpenCL scores and about 14 to 15% faster in the Vulkan scores. The RTX 3050 is 22 to 29% slower in the OpenCL and Vulkan scores, so quite a bit better on this Intel A580. I've added another card into this benchmark, even though this is quite a bit more expensive, the RTX 4060 Ti, but I saw in some of the benchmarks this card was so close to it, so I wanted to add that into the row of things rather than the A770, just to see what some of the competition and how does this perform compared to the competition rather than its own kind of brothers. So the 4060 Ti is 53% faster in the OpenCL and about 40% faster in the Vulkan scores. Moving on to photo editing and Photoshop, the A580 is performing very, very well, and Intel somehow does its magic and really gets their GPUs working really well with Photoshop, and that's the case with all of the R cards I've tested in Photoshop. The A750 is about 5.3% slower in the overall scores. The RTX 3050 is actually 5 to 20% slower in the overall scores. As you can see, the GPU score is 20% slower and the filter score is 11% slower, so that is quite a big of a difference there. The RTX 4060 Ti, interestingly, is even slower, 8.6% slower. GPU score is 31% slower and the filter score is 21% slower. Now, bear in mind, this is not just a single test I've done. This is multiple tests and calculated the average of it, and I've retested the 4060 Ti and it's exactly the same. All of them have the latest drivers available at this point in September 2023, and I'm using the studio drivers, which should give the ultimate or the most stable performance in creative applications. In Lightroom Classic, I'm not going to test it because really, even though GPUs can accelerate certain things in there, in this benchmark you're not going to see the difference, and I've seen the iGPU and the dedicated GPU perform within a margin of error, so there's no point in actually showing these scores. But now, video editing, and firstly Premiere Pro, which is very, very interesting. So the A750, interestingly, is about 10.7% slower in the extended overall scores and about 10% slower in the standard overall scores. And I was thinking, how is this possible? I'm sure this should be slower, but that's the thing with Intel R cards right now. So the A750 I tested maybe 2 weeks ago or 1 week ago before I got this card. And since then, I'm assuming that this 580 driver for this GPU is even more optimized to Premiere Pro than the previous driver what I tested, the A750. And this is not like a very old driver. Everything's exactly the same, just a driver might be maybe 1 or 2 drivers ago. But that just shows that when you're getting this Intel Arc GPU, make sure your drivers are up to date, because it does actually matter and you can get quite a lot more performance. So I'm assuming that the A750 will actually perform even better now, because it shouldn't be 10% slower than the quite a bit cheaper card in here. The RTX 3050 is 19 to 21% slower in the extended and standard overall scores. When we look at the GPU effects in the extended or standard scores, the RTX 3050 is 35 to 36% slower. That is a huge win for the A580. And if you're looking for a cheap video editing card, then the A580 is the best card you can get below $200. Absolutely killer card. Now, the RTX 4060 Ti is actually even slower than this 580. We can see about 1% slower in the extended overall and about 8.4% slower in the standard overall scores, which is quite a big difference. Now, it's not slower in every aspect of this test. As you can see, the GPU effects are a little bit better for the 4060 Ti because probably faster clock speeds and Nvidia cards are very powerful at that point. But still, working with some of the codecs, you can see intra-frame, for example, for 4060 Ti 16.6% slower in standard and extended scores. That's absolutely crazy. And the standard GPUFX scores 10.6% slower. That is a huge win for the A580 again. Arc, Intel, I am loving what you're doing. Please keep going and give us competition for the, 4080, 4090, aspect as well. I want to take things a little bit of a newer level. How does this card compare to some of the, out of its class range? I'm talking about 3060, 3080 and 4070. Now looking at the benchmarks, the 3060 actually gets absolutely wiped with the A580. It's about 13 to 15% slower in the overall scores. It's massively slower than the 3060. And 3060 is a lot more expensive than this guy here. The 3080, look at this over here. Standard and extended overall scores 0.4 to 5.3% slower. Look at the intra-frame score. The intra-frame extended score is 30% slower, and the same with the standard score. We can see that that is the case with long GOP, intra-frame and RAW. So whatever codecs you're actually using, this card is much better at encoding and decoding these, and this is because of the media engines inside. Those dual media engines inside, they're absolutely killer options there. Now you can see that the GPUFX score is a lot faster on the RTX 3080, which we can expect. But if you don't use a lot of GPUFX and just perhaps want to render out the video or playing back video and you're not using a lot of GPUFX, this card is better than the 3080 by quite a bit, which is absolutely amazing. Bear in mind, I've tested this with the iGPU disabled on my 12900K, which means that whatever media engine comes with the GPU, that's the only media engine that we can use for hardware playback. And this guy can play back some of the hardware that Nvidia can't play back. For example, 10-bit 422, H.265. This guy, hardware acceleration, Nvidia and AMD, no can do. And looking at the RTX 4070, which is quite a bit more expensive card, the extended overall score is about 13% faster, which is, all right there. And the standard overall score as well, 4% faster, something like that. So it is faster there, but look at that. The intra-frame score is about 15% slower in both of the cases. And the raw standard score is again better on the 580, which just shows the encoding performance is a lot better on this card. Now, obviously GPUFX, you can see the 4070 absolutely smokes it with this one, but depending which codecs you're using, the intra-frame, especially the A580, is absolutely killing it. Moving on to After Effects, and this is somewhere where I'm getting a lot of crashes with this. Now, for some reason, the lower end cards absolutely crash my test bench with this, especially Intel cards. So none of the Intel cards actually work in there. Somewhere halfway through this, they just crash. I'm still not sure why this is happening, and this is completely clean install of all of the drivers. So there's none of the GPU drivers in there. I've DDU'd all of this clean, but I'm getting a crash in After Effects. Now that doesn't mean that it doesn't work on After Effects, and I can assume you're getting similar results to the Premiere Pro score. If we're looking at the GPU scores, then the GPUFX scores are probably, some of them are better on the Nvidia cards, but at the same time encoding and rendering might be better on this Arc there. So that's the kind of performance you can expect in After Effects. Moving on to DaVinci Resolve. And here I wasn't able to complete the test with extended score. So it doesn't test the 8K score, even though it actually matches or ticks all of the criteria, having at least 8 gigabytes of VRAM to be able to test the extended overall score, but it just wouldn't finish it with extended overall scores. And you can see the same with A750 and an RTX 3050 actually. So looking at the standard overall scores, we can see that the A750 is slightly slower, even though the 4K media GPUFX and Fusion scores are better on the A750. So I'm not sure how this gets calculated, but basically it performs very, very close, within a few percent of the A750. That's what we can see. More interestingly, the RTX 3050 is 30% faster in the standard overall scores. So Intel isn't as optimized to the DaVinci Resolve software yet. And we have to wait for some of the hardware updates, because you can see Fusion score is 71% faster on the 3050, and this is due to the driver mostly, as you can see. The 4060 Ti completes it in extended overall scores, and the standard overall scores is 42% faster. 4K media scores is 24% faster, and the Fusion score is 71% faster, which is insanely higher than this A580. Now moving on to 3D performance, which this card really is, you know, advertised for gamers and getting really good frame rates. But what about 3D creative applications? First of all, V-Ray, it's not supported. Secondly, Octane it's not supported. Thirdly, Redshift, it's not supported either, so we're gonna have to wait for, you know, the support for that to come out there for Vulkan and OpenCL to actually utilize this. But for Blender, we do have support for the A580, so let's take a look at this one. The A750 is actually 2.5 to 5% faster than this A580. The RTX 3050 is about 16 to 20% slower than this A580, which is actually absolutely amazing 3D performance for this. So actually in 3D, if you're using Blender, this is quite a bit faster than your RTX 3050. The 4060 Ti though are completely another level, as you can see. 134% faster in the monster scene, 88% faster in the joke shop scene, and 127% faster in the classroom scene. It's a lot better. What about the power draw? So looking at this guy there, the Intel advertised TDP is actually 185 watts, which I'm never actually seen this pull. The most I can see it pull is 150 watts on Firmark, which usually absolutely saturates the power of this. But the TDP could be the total board power, which means that it uses the other one like VRAMs and other bits as well on the grip GPU. And you might be saying, yeah, that's normal. But actually, if you look at all the other cards, and all the other cards kind of put the TDP onto just the performance or CUDA cores or the calculating and all of these things inside the GPU instead of the VRAM, and they go on top of that. So I'm seeing 150 watts maximum pulled in there, and the temperature is about 74 degrees, which is just all right, nothing major. 24.6 ambient temperature. But looking at the A750, which I have the Sparkle A750, which has a 3-slot card, a bit bigger card, that does much better job at cooling the GPU, even though it pulls more, about 180 watts, and is 68 degrees. So this card pulls a little bit more than the 3050, as you can see, and a little bit less than the 4060 Ti, which is interesting, but cools it down quite all right as well. Now, I want to mention another thing, which is the overclocking capabilities, because on the Intel Arc control, you can, you know, move the sliders and then extend the power limit. But when I did that, you know, max out the power, you know, draw limit as well as the performance slider, put it all the max, I just got a crash with this. So we're gonna have to wait for the drivers optimization, and you're not really gonna get any more performance there, so I wouldn't recommend doing that. Now, so when we're looking at the card design, we can see two 8-pin PCIe power cables, or, you know, slots, ports for your GPU. And if you know the power limitations, then usually there's about 150 watts per 8-pin, right? So 150 watts here, and then you get another 75 watts from the actual PCIe slot power to the GPU. So in total, that will be 225 watts, and our card pulls 150, which would be plenty. Extra 75 watts, what you know, wouldn't really need. But here we have two of these, which is kind of, I think, waste of money and time. We could have saved even more by just adding one in there. You don't really need the secondary slot in there because it's not going to pull that much power. This is much more power efficient, so that's that. And also you can see in terms of the cooler design, they've really tried to make this as affordable as possible, because they've just kind of slapped on a cooler that doesn't really fit in there, because the backplate and the PCB isn't really matching what the cooler this is. The cooler hangs over from the top and then from the sides there as well. But this is meant to be like the cheapest card, and not necessarily the nicest card here, just, you know, to give you performance. 4 heat pipes in there, and then this backplate is actually some kind of metal as well, and there are heat pads in there, you can see on the side there. And that will actually cool some of the VRMs, I'm guessing, on the back of the GPU. And the backplate does get very, very warm when actually testing this. So, the conclusion of this card then. I think this is absolutely amazing card, because the RTX 3050 gets pretty much wiped in every single aspect apart from Octane render, Redshift, and some of the other 3D benchmarks. But the point is that you're really not going to use an RTX 3050 for those anyway, and if you're just using Blender, this is a lot better than the 3050. So it's cheaper and better than the 3050 in pretty much every single aspect apart from DaVinci Resolve. Especially if you're a video editor in Premiere Pro, this is unbelievable card, and you get unbelievable performance out of this one. Like, to beat the RTX 3080 quite a marginal amount in some of the codecs is absolutely insane, really. And for photo and video editing, this is the one. If you're using Adobe products, Premiere Pro, even After Effects, I'd say, and Photoshop, then this card really is for you. What this card isn't for really is 3D rendering. Then I'd still recommend going with Nvidia because the support is much better, even if you go with a 4060 or 4060 Ti. I know they're more expensive, but they will perform better in the 3D applications apart from Blender, which this is better. But other than that, I can definitely recommend the ARC A580. And knowing that there's more updates coming to the drivers, this performance just gets better and better and better, and competition gets weaker and weaker and weaker, which is just very good news for us because we're getting better GPUs at the low price point. So if you want to check this out, I'm going to leave the links in the description below. Now, my friends, if you do want to build yourself the best bang for buck, create a PC, and perhaps want to save money and don't build the wrong parts or buy the wrong parts, then I'll leave the build guides in the description below. Everything is down there. Whatever your budget is, have a look and enjoy those build guides. Completely free. You'll find it in there, as well as this card if you want to pick it up. Thanks, guys, for watching, and I'll see you in the next one. I'd love to know what you think in the comment section below. Bye-bye.